Okay, tonight's notes are going to be on complex numbers. And this is on page 41. Now, complex numbers, we also call it imaginary numbers. So I'm going to put AKA. So, also known as imaginary numbers. So up until this point, if we've got a square root with a negative in it, we said no real solution because we can't take the square root of a negative. But now with this, we are going to be able to take the square root of a negative. So the definition of an imaginary number is so the imaginary number I, and we always write it as a cursive I, is defined as the square root of -1. So that means, I equals the square root of -1. Okay? That's the definition. The imaginary number I is defined as the square root of -1. So to write that a little bigger, I equals the square root of -1. Okay? So if we have a square root of a negative, that's an I. So let's say we have I squared. Okay? Well, that means we have I times I. But if we go up here, we know that I is the square root of -1. So we have the square root of -1 squared. Well, we can write that as the square root of -1 times the square root of -1. And whenever you have the square root of something times the square root of that same something, it's actually just that number. So that means I squared is -1. And we use that quite often. So it is important to know that I squared is -1. So when are these used? Well, let's do a quick example. Let's say we have the square root of -4. Well, if we have the square root of -4, we can actually break this down, like we did with rationalizing, into the square root of -1 times 4. Because -1 times 4 is -4. Well, that'll give us the square root of -1 times the square root of 4. And we already know the square root of -1 is I, so I'm going to write I, times, and then the square root of 4 is 2. Now, I times 2, that's okay, but we like to write it as 2I. And that's how we're going to write our final answer. So I want you to do an example. Go ahead and do that one. Okay, so when you do that one, you're going to get the square root of -1 times 64, which is -1, the square root of -1 times the square root of 64. The square root of -1 is I. The square root of 64 is 8. So then we get 8I as our final answer. Okay? Now we could have different things. So we could have an example where we have the square root of -8. Now, obviously, 8 does not have a square root. So this is where the rationalizing the square roots comes into play. So this will do the same thing. We're going to break it down into the square root of -1 times 8, square root of -1 times the square root of 8. And this is I times, and this gets broken up into 4 times 2, the square root of 4 times the square root of 2. The square root of 4 we know is 2, and we still have this I, so that's going to be I root 2. Now I'm going to have you do an example like that. So I'm going to have you do the example of the square root of negative 45. Go with that and turn your answer. So when you did that one, you should have gotten the square root of negative 1 times 45. Negative 1 times root 45. That'll be I times, and this can get broken up into 9 times 5, which is the square root of 9 times the square root of 5. And we know the square root of 9 is 3. We need to bring down that I. So this will be 3i square root of 5. And the last example we're going to do is going to look like this. 5i squared. And when we do this, this squared by our properties of exponents is going to get distributed in. So we get 5 squared I squared. Now we know 5 squared is 25. And then I squared. Now let's look back up at our notes. I squared equal. Well, I squared equals negative 1. So that'll be 25 times negative 1. And you have to substitute in that negative 1 for I squared. So your final answer is negative 25. Okay? Now that's a really, really quick lesson about complex numbers or imaginary numbers. In class on block day, you will have a worksheet that we're going to go over. That's going to involve all of this, so you'll get a little bit more practice. All right, thanks for watching.